Hi, this is Justin, and thank you very much for tuning into my channel and taking a look at my video. Today there's been the Wispa Virtual Summit going on, so if you missed that, you can go to wispa.org and I'm not sure the particulars, but you should be able to sign up and view the recorded sessions at one point. But if you missed it, you missed quite a bit of information going on today, and it got a lot of juices flowing in my head. So I've been doing some blog posts and stuff like that in between sessions, and I wanted to do a video here on ISP pain points and a little bit of network design. It's going to be fairly technical, but from a high level. So whenever I'm designing or looking at an ISP network, one of the first things I look at is, where are my pain points? What can I afford to lose? What's going to hurt me the most if I lose? Start with that evaluation. With most ISPs, the major pain points are your transport circuits. How do you get internet into your network? If you're a rural ISP, this is really important because most of your options are not, you don't have very many options. So, the scenario with a wireless ISP is you get your first transport. It might be DIA from the local telco, or it might be transport to a data center where you pick up somebody like Hurricane Electric or Cogent or any number of transit providers. Now, some of the terms I'm using in here, I'm not going to go over them. I've covered them in previous blog posts. So in the link below, I'll link several pages on the terms and explaining some of this stuff in detail. So back at it. With a single connection to a data center or single DIA connection from the local telco, that's going to be your major pain point. If that thing goes down, all of your customers are down. Next thing might be hardware. If you lose your core router that's attached to that circuit, that's another major pain point. All your customers are down. So as you grow, and this is what's kind of depicted in the diagram here that I kind of threw together, as you grow, those pain points can be mitigated some. So, that single connection now becomes multiple connections between your towns. Maybe you have a mesh network in between two fiber transports. Now you can, at the data center or the head end, you can start having some hardware redundancy. And we'll go over that a little, and we'll go over some transit redundancy, things like that. So when you're talking about pain points, and we're now this medium-sized ISP, and we've graduated to these couple of transport circuits. We've graduated to maybe some rack space at a data center. What do you do there? Again, look at your pain points. Do you need multiple routers like I've depicted here? Do you need multiple switches in a switch-centric design like I've pictured here? Those are questions to ask. Sure, it's nice to do that, and that's probably a goal that you want to get to. But how soon do you get there? That's usually a question I see a lot. How, do I start with this from the beginning? Do I invest a lot of money in hardware in this really nice network with no customers? Or do I make it modular and be able to layer on these pieces as I go? Much of that is a business decision. If you feel you have the money to do that from the start, one of the things to consider is, how soon am I going to outgrow or outlive this equipment? So if it sits there for 2 years being majorly underutilized, and you only get a year or year and a half of life out of the equipment, is that really worth it? Rather than saying, hey, I'm going to put in something that is, it's going to get me by, but I'm going to grow the gear as needed. And those are business decisions because not only do you have to worry about the hardware, you have to worry about, okay, the people power to configure and rack and maintain equipment, the rack space if you're in a data center. All those things are things to consider. So getting back to the data center. Say we have one transport to the data center. What do we put there? Do we want to put 2 routers there? Well, the first thing I ask is, how far is it between you and that data center? Can you grab a cold spare you have sitting on your shelf as you go out the door and be at the data center in X number of minutes? What's your pain? Is 20 minutes too painful to you? Is 10 minutes too painful to you? And we're talking realistically, because in the service provider world, no downtime is a goal. It's not necessarily achievable. You're always going to have outages on one provider or another, or you're always going to have equipment failure. That's where all this redundancy comes in we're talking about. But where is the realistic pain point? Can you suffer for 20 minutes rather than having a $10,000 router sitting there? Can you suffer for a half an hour? Those are questions to ask. So if you have a cold spare sitting at the office that may serve dual functions, does it replace some gear on the inside of your network or at the edge of the network, so it's just not pigeonholed for one use? That's something to consider. Or do you have a spare sitting in the data center and you say, hey, 20 minutes is too much for me. If I see that my circuit goes down or the hardware goes down, as soon as I diagnosed what's going on with that, I'm on the phone to the data center saying, hey, I'm enacting my disaster recovery plan. I want you folks to, do this, 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 and this, which usually, if it's a cold spare, it involves them going up to your rack, powering up the cold spare, and moving some cables. Now, can that be done in 20 minutes? Maybe, maybe not. Depends on the data center, depends on all kinds of factors. But that saves you a drive, and if that's worth it to you, then great. One of my clients, they have a cold spare sitting in a data center rack right below their production router. At intervals, they power up this cold spare, upgrade the software to the same version as their production router, and they copy over their latest config. Their idea with this is if the production router ever dies, they call up the NOC, tell them to move the cables from router A to router B, which they're sitting right on top of each other in the rack. Power it up and move cables. Boom, they're up and going. They've obviously done a little bit of diagnostic work before this happens, so there's that lead time there. But with automation such as network management software, Libra, Zabbix, Dude, all of these, you have pretty good information to begin with. So now you're becoming a bigger ISP. You're adding more transport circuits, you're adding transit providers, maybe you're adding an internet exchange. Now you're really thinking about hardware redundancy. It's kind of the all of your eggs in one basket sort of thing. You don't want all of these transport circuits, transit circuits dumped onto one piece of gear. There's several benefits to this, not just for the hardware failure aspect of it. One advantage is you can take a router, a switch, whatever offline for software upgrades or other maintenance, and not take your entire network offline. If you have a wireless network and you have enough capacity between, say, the town on the left goes all the way through your wireless network to the town on the right and up your transport. If that's enough capacity to carry your load, and going the other way is enough capacity to carry your load, then up here we can reboot a switch, we can reboot one of our layer 2 switches, and we can even reboot one of our layer 2 routers or layer 3 routers. Now things might get a little slow, you might have a little convergence time, but it's not going to be a hard down type of a situation. So, the transport paths make a big difference. The what's connected to what. So in our example here, we have 3 ISPs spread across two different routers. We have an internet exchange, which if an internet exchange goes out, if you lose connectivity to it, you can always send the routes out to your commodity internet transit providers. And most internet exchanges have dual redundancy, whether they be dual route servers, you can get a dual connection into the fabric, that sort of thing. So you could actually take this internet exchange here on the left and put it on both your routers. That's kind of a more advanced topic. So, how does this all kind of play into ISP network design? Well, look at it from a modular aspect. In my diagram here, if I lose my layer 3 router at the left, what's that going to affect? If I have to upgrade that, if I want to go from, say, MikroTik to Cisco, or MikroTik to Juniper, or even white box routing these days, what's that going to affect? Well, if you have a real modular, very redundant design like this, your pain points aren't as bad. You can say, hey, I have this brand new, whatever newfangled router that I want to put in, but I don't want to, do major surgery to my network. So if you're talking your routers connected to your ISPs and your exchanges are modular, where one can fail and everything survives, that also plays into upgrades and all of that. Same thing with your switches. This is starting to become really important for ISPs going from 1 gig to 10 gig. Now they're looking at switches that can do 25, 50, sometimes 40 gig switches. So what happens when you have a transit provider that you're, oh man, I can justify a 25 gig connection to them. I need to put in hardware and switches to deal with that. Well, if you just have one set of switches, one set of hardware, that's going to be major surgery. It's going to be downtime. There's probably, I'm not saying there will be, but there probably will be misconfiguration issues. Maybe there's configuration issues on the ISP side. So when you bring up all this stuff, it doesn't work and it's stuff not out of your control or out of your control. So, take a look at all of that. Cisco has always done the 3-tier design. You have your edge, your access, and your edge, your core, and your access layers. So in our little diagram here, edge would be our layer 3 routers, our cores are our layer 2 switches, and our access are our customer towns, where we're actually providing the access to. So when we look at our core layer, there's very little firewalling going on. We want to move packets out of our network to our providers as quick as possible. At our layer 2, our switch-centric design, we're still moving packets around quite a bit. So we're moving them to firewalls or downstream routers or things like that. So we're still moving it around quite a bit, but at that layer, we're handing it off from the transit to, say server clusters, or we're handing it off to access layers. And then at the access layer, that's where we do our QoS somewhat. We do our firewalling, things like that. We're able to take these different layers and modularize them. That way, good upgrades, it's easy to go to new gear, that sort of thing. So I wanted to kind of go into that a little. Mainly, I'm trying to get back into doing a video at least every other day, if not, every day. So while this hasn't been necessarily a very in-depth topic, I wanted to put it out there, get the thoughts going. the typical like this if you like it, subscribe to the channel, follow me on my blog at blog.j2sw.com, and thanks for listening.